cloud deployment model. So there are, if it see, there are three kind of cloud deployment models. The apart from the legacy thing, and legacy, we are having our own data centers. There we are deploying our resources. We are creating our servers and application over there running. But if we talk about the cloud, there are three options. So you should hear about the private cloud as well. So private cloud is what it is. It's just like a VMware. What exactly it is? In the private cloud, you will get one hardware, and you can do the virtualization over that hardware. What that means, like, let's say you are having a laptop, you are having a machine which having 8 CPUs and 64 gigs of memory. But your the application you want to run on that machine is require only 4 and 16 combination, right? So your remaining compute and power and memory is free, right? That is not being utilized. So that's the limitation with the earlier uh, uh, the legacy thing which we are using. But after we are having this option of virtualization, what we can do, apart for that 16 to 64 combination, I can logically separate it, right? I can logically earlier it is like that. Let me draw some diagram, then you are able to understand.
So Danish, you mean to say that earlier it is like a fixed kind of stuff, right?
Yeah,
So
fixed and
you
just
can
like we are having our laptops, right? Everything is fixed.
correct. So we cannot utilize it, will be waste.
Waste. So what the virtualization will do, I will show you. So let's say this is my one machine, hardware, right? Hardware 16/64, right? So on this machine, what is there? One OS will sit, right? Let's say Windows, and on top of it, I'm running my application. Yeah, but that application's actual requirement is, let's say, 4:16, right? So my resource which is available to me, which is free, actually free, I'm not utilizing that, are this. Right. So my 1248 is free, right? But the limitation is that during the legacy thing, that I can't utilize this. But by using of hypervisor technology, what we can do now? So when hypervisor came into the picture, right? What will happen? One more thing will sit over here. It's called hypervisor between these two. Hypervisor. So by using the hypervisor, I can logically separate. Okay, I can logically reserve the resources. So now I can create 2 machine, 3 machine, 4 machine, whatever I want, and that too on the same hardware, right? So like say it is Windows, and I would like to run one more application on the Linux based that I can also run. Earlier, the limitation is I have to stick to the operating system, not Windows. So I can use only Windows supported application, and I can install on those only. But now with the help of hypervisor, what I can do, hardware is same, right? I can run Windows. I am just on top of that hardware. I am having one hypervisor that logically separate my resources, and I can run Windows server as well and Linux as well on same hardware. So I can use this for another resource. Here 1248. I will use over here Linux, and I can run another application over here, right? Linux based application. So that's the uh, way the hypervisor will work, and we can logically separate our hardware. Hardware in the backend hardware will remain the same, but logically I can create multiple machine over that particular hardware, right? And that is exactly happening in the cloud as well, in the backend. So if we see the private cloud option, this thing is supported in the private cloud as well. Okay, so we can logically create multiple machine over there as per our requirement, right? So that is called hypervisor. So but even though I can have the on-prem as well, but it is having a certain limitation, right? My hardware is still fixed. Let's say I need, and I need to, I am having this resource, and I need another, I am having one more application which I would like to run, and that needs another 16 to 64. So then again, the same process, I need to procure the hardware. Although I can do the logical thing, but I need to procure another hardware. The same limitation I am having over here. But this is the better utilization of available resources. What we call the private cloud on-prem that sits in my data center, right? Next option is all in cloud. All in cloud means everything will be hosted on the cloud only, right? I am the cloud. I am using only cloud only model, and I am a new organization, a startup is created. The startup is directly started from the cloud only. Okay, so there is nothing in on-prem.
Yeah, Danish, your voice is somehow. I don't know.
Yeah,
It's
yeah,
my side
correct.
only. Or,
Actually, no. Actually, I think it is from the Danish side. Previously, I was thinking that it is on my side, but
अभी आपका
sometimes
जो
it is
आवाज आ रहा है
breaking.
दानिश वो बहुत अटक रहा है और
Uh,
बहुत एकदम से फिर बोल देते हो मतलब ये लेट मतलब वाईफाई में है क्या देखना है।
एक सेकंड रुको, मैं कुछ करता हूँ. Hello, hello.
Yeah, Danish, you are
yes,
able to hear.
Danish.
Yes, we
Is
can
better
able to
now?
hear.
Yeah, this is better.
Okay. So the next option is all in cloud. Like one startup company is there, or the company is which is establishing new, so they have started their infrastructure from cloud only, right? So there is deployment model is all in cloud, right? So that's another stuff. Third thing is hybrid. What it means? It means I am running something over cloud and something over on-prem. And if you get a chance to work with any organization, then 95% of the organization is running over this model, hybrid. They are running something on-prem and something on cloud. And what's the reason behind that? The any established organization, right? Since ages they are using this this technology, either on-prem cloud virtualization or are using the legacy thing. And they have invested so much of money on that. And they don't want to get rid of like scrap scrap it. So what they are doing, they are doing their application, they are deploying their new application over here, but they are also utilizing this stuff by, let's say, doing keeping the backup of it over here, because they are having space, right? Storage space, it is still usable. Or some lightweight application, not critical application, they are hosting over here, right? So the current deployment model is this hybrid only. Apart from that hybrid, we are also using multi-cloud model. Like I told you yesterday, let's say we are all most of the organization are using Microsoft AD, right? Microsoft email ID. So we need to integrate that, so that we also comes in this model, multi-cloud model, hybrid model. right? And another use case of using hybrid is, let's say one application is running, one company is there in Bangladesh, right? And it's a bank. They want to use the cloud, but the thing is that Bangladesh doesn't have any data center. Understood? The region, any AWS region over there, even though not any CSP is having any region in Bangladesh. But as per the regulations, like in our country, the customer data should be in the same geographical in the same geography of the country, right? Let's say what it means that for a bank who is running in India, they should keep their customer data in India only, right? But India, we are having data centers, regions, AWS regions in Mumbai and Hyderabad. But Dhaka, they don't have. What they will do? They will create a local infra, right? Right, on-premise stuff. And what they will do? They will keep customer data over there, right? And their application will be hosted on cloud. Now, what will happen when someone try to access the application, right? So it go to here on the cloud, but it will authenticate it from on-prem. Understood what I am saying? So in that case, what will happen? My regulatory compliance is also through, and I am also getting best out of cloud. So only authentication thing is going to here. Apart from that, everything is hosted over here. So I am using elasticity, scalability, right? High performance, everything, availability, all the benefit of cloud, and I am doing the compliance as well. There is a use case, another use case that we need to use the hybrid model, right? And you will get to see most organization work in this kind of models only, hybrid one. Okay, this is clear? Any doubt over here?
So Danish, just one question,
Hmm.
like if as we took the example of the Dhaka,
Hmm.
so there first the initial authentication will happen on-prem. Means in Dhaka, they will establish some kind of hardware over there.
Yes, yes, exactly.
Okay.
And we need to establish a connectivity between our cloud and this on-prem.
Okay.
So there are various options on AWS side, like we can set up VPN, we can set a direct connect, right?
Okay.
We can also authenticate over public internet as well. There are various options to have a connectivity between these two.
Mhm. Okay. Thanks.
Okay,
Mhm.
so these are the use cases. Anyone else having any?
Danish,
Yeah,
in this all in cloud means I didn't get it. What is this all in cloud? It's mean that that mixture of all will be available in cloud. That what
everything.
you going to say?
It means everything in the cloud. That the case I have shown you, the Dhaka one, right? That
Correct.
in Dhaka. But let's say you are hosting in the Mumbai, so you can keep this as well
So,
in
means
cloud.
if in my knowledge, if we can segregate in this example, like the hybrid one is the industries in which some hardware kind of model is connected with the company side and some of the part has been taken to the cloud.
Cloud.
Is it the hybrid?
Yeah, mix and match,
Mix
both.
and match. Means
Yeah.
in telecom, if suppose it's a server side, most of the servers are on a cloud, but some of the parts of the MME is in hybrid. So
Yeah,
hybrid is cloud. Correct?
like in case of cloud, in the case of telecom. So even in you are having data center in India of Amazon, but
Uh-huh.
you can't host your customer data, right?
Yes, yes, yes.
You can't host your customer data on the public, because it's a public cloud,
It's a
right?
public.
So you can't put your customer data over cloud. So in that
But
case also you need to
one
have
more
that
thing,
in.
Danish. I'm sorry, but the all-in cloud is not always a public. It can be a private also.
The private cloud means you should have that
Yes,
data center.
public cloud means the only our company can access the
No,
for
no,
this. No?
that's true. That's true. That is a separate thing. But
Acha.
on we the AWS, Azure, GCP, we call it a public cloud.
Okay. Yep.
Okay,
Pita.
there are
ठीक
three
है.
kinds of cloud. I will tell you: public cloud, private cloud, and government cloud.
Okay. हाँ. ठीक है.
Okay,
Fine. Yes.
private hosted in your own space.
Yes.
Public,
Yes.
anyone can create over that account. Anyone create that means doesn't mean that anyone access your data. There is a different thing.
Means the
Like
Google, the Gmail we have created in the cloud.
like the public sector companies. right? So banks are public sector. Anyone can go and create, open their account. But does it mean that someone else will access your account and withdraw the money?
The Gmail, the cloud, the Apple cloud, you
Yeah, everything's the Google Cloud, GCPs, all are public. These are public
Okay.
clouds. Okay.
Okay.
So and the third is the government cloud. Government cloud is specifically designed for the US government. Okay. And only the US government's application, their data will kept on those cloud, and no one can, no one else from the outside can access that data, or can't we even can't create our resources in that data center. Okay.
Oh, now there will be a three type of cloud, that is public, hybrid, and private. And that one more which you have added it as a government cloud, it's coming under which?
Government cloud is specifically designed for, it comes in all in cloud only, and that
Okay.
that can only be accessed by a government, US government.
Okay.
We'll see when we go to the AWS console. It will come over there, but you can't create resources over there. Okay. Let's go to the next time. So there is one graph, all in cloud versus on-prem, right? And you can see over here, the yellow one is your capacity, on-demand capacity, and the blue one is your actual demand. So like I told you yesterday, in the cloud, let's say I have set the threshold of 5% or 10%. You can see this is the actual demand of blue, and as per this demand, my resource, this is compute capacity, right? And this is time graph. So as my demand goes, my resources are increasing. I have put the delta out, let's say 10%. So it is just above that actual demand, right? I am getting the resources as needed. But if we talk about the on-prem, right? So the actual demand is same, but here I have created resource here. This one is the green one is the my resources. You can see this is over provision. Even though my demand is this, but this is I'm not utilizing, right? Here my demand is increased, but I'm not utilizing. Yeah, under provision, right? I am not having the resources. And here again, I've increased the further, but here again, over provision, right? So I am not utilizing my resources very efficiently over here. But in cloud, as soon as my demand goes, my resource come, and when it come down, again it will come down, right? So we need to set the threshold. This is called the auto scaling. On the cloud side, we can scale the resources as and when we need it, right? And we can also define the auto scaling system. By doing the auto scale, we need to set up the threshold. Let's say I am having one server, so I can set the threshold that once the server utilization goes to 85%, it will create another resource of same configuration, right? So when I define the threshold, what will happen? As soon as my machine goes to 85%, it will create another resource, right? And after that, with the using of load balancers, my traffic will be distributed between these two.
But then I have a question. So it all license based, right? I mean, how many resources you're getting into in the license? Say for example, I'm taking 16 core and 64 GB memory. When my utilization increase, so as per you, the resources automatically will be added into the application as or whatever it is.
No.
But
So what will happen? I will show you in the Megan. So let's say we are having two machines. This is a one machine, right? Machine one, right? And my application is running over here. So this is 16/64. Right. So my application is hosted over here, right? So what will happen? Once this application utilization goes high, Then one more thing came into the picture, load balancer. So what I need to do generally, when I would like to create the auto scale, I need to initially create load balancer only. So whatever traffic will come, traffic will not come to here. All the traffic will come to this location only, LB. And let's say assume this thing is not there as of now. So traffic will come on to LB only. So whenever we need to create the solution, which should have the load balancer, it should be designed like that. Right. So it's just like that. Any application is having three, right? Three component: front end, middleware, and back end. Right.
Okay.
So in this one, the middleware is a load balancer.
Yeah, middleware. We can use load balancer as a middleware and
Mhm.
at the back end as well.
Okay.
Because front end doesn't need so much of capacity, right? Everything
Mhm.
should be hosted over here. So this is middleware. So what will happen? I have defined middleware over here in the load balancer, and initially whenever all the request is coming, it goes to directly to here, right? And once this utilization goes high, it will create the replica of it. So what will happen in that case? It will
Read performance will, I think it will improve.
so it will distribute the load between these two, right? And one more thing, what will happen once my resource are let's say again my traffic goes down, right? So I will set the threshold that when utilization of my LB or the target group is less than 20%. This is called the target group at the LB side. We will see all this stuff
Okay.
when we will read the load balancer and auto scaling. So this we call the target group. So we will put the threshold that when my target group's utilization is less than 20%, then kill one. So then what will happen? They will kill this resource and direct the traffic to again here, right? Then again it will go to earlier it was 2020, then it will 40% again. So we can define auto scaling like that. It can automatically scale up and scale down.
Got it. Got it. Yeah. Thank
Got it?
you.
Oh, but this the second which you have got created automatically, it is like already been said that it will create automatically.
Yeah. We need to define the threshold.
Okay,
And it
so
will be
the memory utilization and the core utilization will be get taken from the same, or it will be take the new one. How it will be?
new resource only, complete new resource. It will not
Okay.
get the resource from here. It's another EC2.
Okay.
Okay. So the same advantage and disadvantages, right? No upfront investment, everything is OPEX, low ongoing cost, focus on innovation. All the stuff which I told you yesterday, the same thing. Another one thing I am not told you yesterday. The biggest advantage is geographical advantages. What it means? Let's say you are having one organization, right, which is running in India, and tomorrow there is a plan that after 3 months I would like to launch my product in US, right? And the US is having again same compliance. You should host the data center over there. And apart from that, one more thing is that let's say there is no such compliance, right? And you want to launch your product in US, right? So what will happen? You have launched your product over there, but your data is in India. Your data center is in India. You are hosting your application in India, in your own premises. So definitely there is a very high latency. If someone trying to access your website, yeah, to purchase your product from US, its latency is really high. So your experience is not good, right? So what you need to do, you need to create your data center in US also. Generally, companies do like that. That whenever they are crossing the boundaries, they should create their resources in their respective countries as well. Their data center, they should host their application over there. Just like I give an example of Netflix, right? It's a US based company, but if you want to release a Avenger Hindi movie, then they need to host that Hindi movie in India only. Otherwise, people will get the buffering, right? The latency will be high. You will not get the high resolution quality of that movie. So you need to host over there. Let's say cloud was not there, then what will happen? I need to set up my data center over there in US also. And how much time and it gonna take? It gonna take at least a year to set up and get all the permissions, right? You need to start it from the scratch. But if we talk about cloud, right now you are running your application in Mumbai and you want your application should be running in the US as well, North Virginia, NV. So you can easily do that. You just create the backup of that, the current application resource, and just share it with the another region. You can cross account, and you can also get another account in the US, and you just share it, and you can create over there, right? So
No,
if you
didn't get Danish. So you mean to say that the data center should be created in the US, or only that the account has to be created on the cloud to access that?
no, even in the same account, I can
Okay.
create multiple. I can use the multiple regions. So in the
Okay.
same account, I am also able to create the resources in North Virginia. I am also able to create resources in Mumbai.
Okay.
With the same account, we can do.
Okay.
Okay, it's technically possible, not a limitation.
Okay.
Okay, and why I told you the another account. So in some cases, what will happen? So let's say you have launched the resources in India, right?
Mhm.
Your primary holder is your address is India, but
Mhm.
in the most of the times, what will happen? Every country is having their different taxation system, right?
Yeah.
Yeah. So what will happen? Even if you launch your resource in US, your billing will come to your India office,
Correct.
correct?
Correct.
But if you get another account for US, then the billing will goes to the US organization.
Correct.
Okay.
Mhm.
So we used to have multiple locations as well, multiple region in a same account as well. But generally, companies isolate the things, and the reason is like I am having production workload, I am having dev workload, I am having QA workload. Different kind of workloads are there, right? So
Mhm.
generally, what companies are doing, they are creating different accounts for different kind of workloads, and the reason is the person who is looking after development, it should see only development stuff. So one important terminology we will use in the cloud, it's minimum access policy. What it means, the person who needs the access to the development, he should only get the access to the development. He should not see what is running in the QA.
Okay.
So we always follows minimum access policy on the cloud side. What is needed, we should give only that, right? So if a person can sleep on a single bed, right? So we should give him only a single bed. We should not give him a double bed to sleep.
Okay.
Okay. So that is called the minimum access policy on the cloud side. And we will do the connection setup, all those stuff that it can communicate. Like India data center can communicate to the US data center with the help of transit gateways. Okay, and that is much needed. Okay, what you can do on the cloud? You can do application hosted, you can do backup, content delivery like Netflix and Hotstar, the local cache. You can do website hosting, enterprise ID database, the normal stuff. Now just go through the terminology. Okay, so if you are not able to understand, then don't worry, we will cover all these things as well. Just go with the technology terminology. Like firewall, you know firewall, right? It's a wall between us and the bad guys, which will create generally, right? Even in our laptops, we are having firewalls, right? We will restrict the access. So the same thing over AWS is security groups. So here we are allowing some ports, some IPs, right? And restricts access over there. Similarly, we can do the same stuff with the security group over here. Like here we are having access control list. Again, we are having same stuff, network access control list. Administrator, just like you are creating the multiple users in your Windows machine, right? In the server, Windows server, you are creating multiple groups, right? The admins, right? The power users, So similarly, we can have the identity and access management, IAM, on the cloud side. This is the security stuff. Networking, we are having routers, their connection, switches, LAN, right? Here we are having two important stuff: load balancers and VPC, Amazon VPC, which means virtual private cloud. Okay. Servers, we are having this hard racks. Here we are having AMIs, by which we will create EC2. On the storage side, there are different terminology, the legacy thing. Here we are having EBS, EFS, S3 RDs. We will cover all these. Okay. Advantages or terminology. Okay. So what is that? High availability means AWS promise certain amount of availability for all their services. Like in case of S3 is the storage solution, they will offer you 99.99s, right? So it is highly available resources. They will always try to upkeep your resources on the AWS side, right? So if something is down, then they will immediately inform you, right? And they will try to minimize the impact on that. And I will show you how we are achieving this high availability, how we will create our architect to achieve that. We'll explain you details. But as of now, you should understand that what is high availability means, that it should be available always, right? The minimum downtime. Fault tolerance.
Means high availability, when you say that accessibility will always be there, it is 99.9%. So it means that no downtime.
No downtime, exactly. No downtime.
Okay.
And there are certain ways by AWS offering you this, and we need to retune our architecture as well to achieve that. So there are certain responsibility from AWS side and certain responsibility on our side, by which we can achieve the high availability. Okay. Fault tolerance, like say your hardware on which your EC2 is hosted is down. It is having some fault. So it should withstand immediately. So I will give you an example. If say, because they are also running on hardwares, right, and the machine can down. So on AWS, if your hardware fails, underlying host, we call it underlying host to the hardware what is sitting in the AWS region premises data center, and if it fails, it will be come back within 10 to 15 minutes. There is amount of you say resources via AWS is having, and they are that is so fast. They are within 10 to 15 minutes they are able to recover your resource, right? Fault tolerance, or let's say your complete data center is down. So you so one thing is that which is responsibility of AWS, like fault tolerance, that their hardware is down, then they need to make it operational again as soon as possible. But some responsibilities from our side as well. We should design our application is like that. Let's say my hardware is down. Let's say I am having one application, right? Application is running, and it is running with 16 core and 64 gig of memory. So what I can do, I can use two machine in place of one. And what I will do, I will put a load balancer between these two. So I am having additional level of fault tolerance. What it means, that earlier I am hosting application on one server. Now I am hosting application on two servers. If the application is supported, this kind of terminology. So what will happen? Let's say my first server is down, then my second server will able to serve the people, right? Serve my users. So there is a way to achieve the fault tolerance as well. So in place of monolithic architecture, right, dependent on the one resource only, EC2 only, I should distribute my application, right? Some component will host it on server A, some component hosted on server B. So the people will not get out of this error, the server is not accessible or your application is down. So there is a concept of containers only, containers also, that if you go to Amazon, Let's go to Amazon.com. So let's suppose all these applications hosted on one server only. So what will happen if my server is down? Then everything will go down, right? Your website is not reachable. But let's say what in place of using one server, I'm using a 10 servers or 2 server, 3 server, 4 server. And what I have done on that, okay, what I am doing on that. So it is having multiple categories, right? Fashion, mobile, TV appliance, there are multiple options are there. So what I will do, these 4 things I will host it on one server, these 4 in another server, and these 4 in another server. So what will happen? Let's say this is down, right? This server is down. Then this is not impacted, right? People will able to access these sections, right? So purpose of this, the distributed architecture is that I should minimize the impact when there is a downtime, right? So these earlier what is there? It is there was a monolithic architecture, everything depending on the one stuff, right? But then distributed architecture, these all 3 servers are independent of each other and they can run independently, right? So we this one of them distributed architecture nowadays, and it's totally dependent on application.
Danish, you are in mute.
Yes, I know, I
Oh,
put
okay.
that on mute.
Okay, okay, okay.
So this is monolithic architecture. Scalability, what is the meaning? Scalability, I told you, is we also call it a horizontal scaling. Horizontal scaling means when ability to easily grow in size, capacity is
Whenever
located,
we are required, whenever the capacity is demand, it
it will
automatically improves the
no,
growth of the.
but there is a horizontal scaling. So this is
Okay,
the
that's
example of horizontal scaling, right? You are having one resource of 16.4, another one is created over here. This is called the horizontal scaling. That means you are creating another resource of same capacity, or maybe the higher capacity also you can create, right? So this is called horizontal scaling. Another is elasticity. What it means? Just take the example of elastic rubber band. You can stretch it up. What it means? That currently it is running 64. Elasticity means I can make it 832. Okay, the same server. I am not scaling it horizontally. It's called vertical scaling. That is called elasticity. Understood? Understood the difference between elasticity and scalability?
Yes.
Danish, can you
Ganesh.
please repeat this again? Actually, scalability and elasticity.
So scalability is what I have shown you, this one.
Hmm. If the
So
existing one we keep on distributing.
yeah, just left it. Don't see this as of now. So you are running one resource with 16.4. Another resource will be created with the same configuration or the higher configuration. It is called scalability. I am
Hmm.
scaling my resources. Earlier I am running with one, now I am having 2.
Hmm.
It is called scalability. Elasticity, just like a rubber band, right? In place of creating another resource of here, I am just keeping this to 832.
Okay, okay,
Okay, 832.
okay, okay. Keep on increasing the existing one.
Existing resource. Elastics, like the rubber band, you are stretching that.
Hmm.
There's
Hmm.
an example of elasticity.
Hmm.
So these are the important terms when you go for an interview and someone will ask you that what is the benefit of a cloud, high availability, fault tolerance, scalability, elastic, right? Okay. Another thing is cost and how that is benefit. We are getting benefit of that cost model. It's a on demand. Like I told you yesterday, if I am using a resource for 1 hour, then I need to pay only for 1 hour, right? Pay as you go model. You will get billed only for the resources you are using, right? Earlier, what was happen? If I procure a hardware and it is keeping in my premises, then it means I have invested a capital. If I use or not, then I am paying for that. I already paid the capital and I need to bond the OPEX, right? I need to pay the OPEX charges. But here everything is pay as you go model. So earlier, what is happening in the industries as well? There is a IT team, right? And what is the IT team is having? The data center ownership is with IT team only, right? So if say the marketing team is came and they want some resources, they want some server, so they put a request to IT team that I want your resources, please allow to me. So all the budget of infrastructure is allocated to IT team only. But nowadays it is also distributed. In first every every team is having their different infrastructure budget nowadays. Like marketing team is having their individual budget, sales team is having the individual budget. So when we are deploying the resources on the cloud, what we are doing, we are putting the tags that this is a server I got from marketing team. Then when the bill will be generated, right? So the bill will have the segregation. The total expenditure is 1 million. Marketing team has costed 100,000. Sales team 200,000, right? Actual IT team is having 300,000 of billing. So we can segregate the billings as well. So nowadays every department is having their different budget, right? So it just don't it's not like that everyone is consuming your IT budget, right? By this we are further try to distribute the ownership and people are responsible for their own budget. Earlier what is happening, that money is going from only from the IT pocket, right? So marketing will not bother. So even though they need 4:16 resource, 4 CPU and 16 gigs of memory resource, they will ask for 8. Then my application should always keep up, and I will have the best experience. But actually, they are not needed, right? Actually, it's not needed. But now, if the billing comes to you, then what it will happen? Then you will use wisely, right? Because that's in your mind that if I put additional resources over here, then if a new application comes to me and I need to deploy it, then I need another resource and it comes to my cost center. So people try to use only whatever they needed. And actually I'm working in a live environment, so I can understand and I can relate it with it, that actually whenever the resources are not needed, people just ask us, please get rid of that. We don't need it, or we need it after 3 months. Please stop it. So one more thing is that let's say you are having one EC2, one server. So earlier, what is happening on the cloud in the traditional on-premise stuff?
EC2 is your storage, right?
EC2 means elastic compute cloud.
Elastic compute.
Compute cloud, yeah. So let's say a server. Just take the example of server. I'm having one server. The server is having two components, right? One is compute power, CPU. Another component is storage. We're having two components over here. Okay, in the traditional stuff. But even in the, if we talk about the on-prem cloud, these two are segregated, isolated with each other. So server is having only the compute power; it doesn't have any memory, right? Earlier it is the same, but even in the on-prem, if we talk about the on-prem cloud, those are isolated with each other. So let's say if something is happen with this, some mixed functionality over this, your storage will be not impacted, right? And cloud mastered it. Cloud technology had mastered this concept. What they are doing, your server is hosted somewhere else and your storage is hosted somewhere else. It is not kept alongside. And what they are doing, they have established connectivity between these two, right? So if something is happen on your server, someone has by mistake rebooted your server, so your storage is not getting impacted. Or let's say fire catch up on the CPU on this server, so your this storage stuff is intact. And another advantage is that let's say your this hardware collapse, then you're still having your storage, So your C drive is D drive is sit over here. C drive, D drive, E drive. And what you can do, you can spin up another server and just attach to that. And it will work like the server as it was working earlier. Right? And why if you talk about the cost benefit, there is a huge cost benefit of it. And I will tell you what. So if we talk about the resource over the cloud, there are two costs coming to us. One is this server cost, CPU. Let's say it's coming around $20. The storage cost is $10. So when your machine is running, what will happen? I need to pay 20 plus 10, $30. Right? Okay. And let's say you don't need machine as of now, right? The person, or it's you take the example, it's a development box, right? The development team will work on your business hours, 9 to 5. So you need this machine only to 9 to 5, right? But if you go to traditional way, you need to upkeep this machine, and even you stop it, it will charge you. But on the cloud side, what is happening? On 95, I am getting the cost of $30 per hour, right? $30 per hour. But after that time, what I can do, let me open one Excel. I will show you the calculation. Right. So my $20 is my server cost. This is my storage cost, $10. Right. So what the cost I need to pay? I need to pay 20 plus 10. Right. And let's say I'm using for 9 to 5, 8 hours. 8 hours, and cost will 8 into $240 I'm paying over here. Right. Now let's go to here. And sorry, 24 hours. My bad. So I'm paying $720 for this server. Right. Now I'm using only for 8 hours. So what I can do, just multiply this with 8 server cost. Storage, I need to pay for 24 because I can't delete my data, right? I need to pay for 24 hours. So what is the cost coming over here? $400. So you can see I can reduce my cost, right? I can reduce my cost by 44%, right? I can save the cost. And how? By shutting down my machine. So as I told you, AWS is going to charge you on per hour basis, right? So if I upkeep my resource for 8 hours and for the rest 16 hours, I will stop it, right? Then AWS is not going to charge me anything. And if you wonder what about my data is already here on your storage drive. It is not impacted. And when you make it up again, then it will automatically attach to this, and your machine will be in the same condition when you have shut it down. So that is how we are using it smartly, right? And utilizing the best available solutions we are having. Understood this concept?
Yes, Danish.
Okay. So generally we are using this for dev machine. We will write down some automation scripts that at 5 p.m. server will be automatically shut down, and in the 9 a.m. in the morning it will be automatically get up. So by this we are already saving 40 to 50% of the cost. And one more, not these 8 hours. There are Saturday Sundays as well, right? So if you talk about only 20 to 23 working days, so we can save it further. Okay. So if we now see how much we are saving in the month, so it's this is the cost, and this is, let's say, multiply with 23, 57% we are saving. Right? It's a huge cost. So this is how we will achieve our cost benefit over here, right? The deployment model I have covered. Now, one more thing came into the existence. Infrastructure as a service, platform as a service, and software as a service. There are three different terminology on the cloud or any hosting strategy. This is the hosting strategy we are talking about. My application deployment model, infrastructure as a service, IaaS, PaaS, SaaS, right? And it's a some confusing term. So I will share one picture with you. That is pretty much, so people generally get confused with this. So I'm having one good picture to understand it. Yeah. Just take the example of this pizza, right? You want to eat a pizza. So what are the different ways to have that, right? So first one is example of on-prem. Second is IaaS. Third is PaaS, and fourth is SaaS, right? So blue one is you manage, green one is the vendor manage, right? So just relate it to the real world example. So traditional, everything is needs to be set up at you. So you want to eat a pizza, what do you need to do? You need cheese, you need toppings, tomato sauce, pizza dough, fire, oven, everything. Everything you need to arrange. And you are making it at home. That is, you are taking the products from the market, the raw products like cheese and toppings, and you are preparing, or you can making it at home. That is an example of on-prem, made at home. Next example is pizza as a service, IaaS, infrastructure as a service. So what you are doing over here, you have taken these things from the market, right? Even the pizza dough is also you have procured from the market, and you are just baking it. That's it. You are baking it. Everything is ready made. You need to bake it. This is example of IaaS. Similarly, if we talk about server stuff, so like this is your on-premise stuff. You are hosting your application on the on-premise, and you need to do from the start to the end, like from setting up a hardware, right, to the OS, to the application installation, everything you are managing. Understood? And you need to patch the server as well. That OS and application patching, what you need to do. Infrastructure. Just take the example of EC2. EC2 is you are just responsible for there on the top of the software part. Hardware, the underlying host is taken care by AWS only, right? So you are just baking the product, right? So you are just running, managing the OS operating system of over here, right? And your application. Take and bake, right? Third thing is platform as a service. Platform as a service means pizza delivered to you. You have called to the Domino's and they have delivered you the pizza. And what you need to arrange then in that case, you just need to arrange a cold drink or a dining table. That's it. And you are eating that. So the on the AWS side, the alternative, the exact thing which we call a platform as a service, just like you can use RDS, right? So you don't need to manage the OS, you don't need to manage the underlying hardware. You just need to do the installation. That's it. Your application configuration you need to do. It is called as a platform as a service, right? You don't need to manage anything over here. Just need to arrange the dining table and soda. And the last thing, and this is an example of pizza delivered to you. And last is software as a service. So in that case, you're just going out to the Domino's and eating the pizza over there. So nothing needs to be managed by you, right? Everything is managed by the someone else. Software as a service. So you can take a software as a service example is like your AD, Microsoft AD, right? Your Gmail. You are just directly using the application, right? You are not managing its database. You are not managing its OS. You are not managing its underlying hardware. Everything is managed by someone else. You are just using it. You are just eating it, right? So definitely to understand these four concepts, it will take time, but this is the simplest way that someone has put this picture over here. Okay, well, let me share this picture with you. Why? And I will upload this to our repo as well. So anyone is having any doubt over here? Definitely it needs the further explanation when we actually deploy the resources. But as of now, I can explain if you are having any doubt over there. Because people will ask you, what is IS, PaaS and SaaS?
So in IIS, you mean to say that the uh, uh, means
I am
the
utilizing the infrastructure of someone else. Like you can say that I am having one data center, right?
Mhm, mhm,
And one more company is there. Like I have given the example of NDJC.
mhm, mhm.
So NDJC, what he has done, he is having the resources already on the Amazon premises. He let other people use that resources. So hardware is managed by Amazon only, right?
Mhm.
And they are deploying their servers over there. So there is an example of IS, infrastructure of someone else I'm using.
So you mean to say the hardware is managing by other vendor and you are managing your own application. That's it,
Yeah,
right?
on application and operating system. Yes.
Application and operating system, right?
Yes.
Okay.
Exactly.
Application and operating system. Okay.
And in case of PaaS, I am not managing the OS. I am just managing the application.
Okay, you're not managing hardware as well as your
OS
OS. You're managing only the application.
application.
Okay, okay. And in SaaS, in
You,
simple term, you are not managing anything.
you are just using the application.
You're just using the application. That's all.
That's all.
Okay. That will be the most simplest
Yeah, they're the most simplest way.
to make it understand. That's it.
Yeah.
That's got it.
Okay. So if anyone is having a doubt over here, or we are good to wrap up now.
You're good.
As
good.
of now, it's okay. Yeah.
So if you are having any doubt further, we can discuss in the next class, or you can just put on the chat. I will reply over there. Don't worry.
Okay.
But
Uh,
please be with me. I will able to help you out to understand the cloud in the best possible way, right? So don't worry on that.
Okay.
Sure, Dhanesh.
Sure. Okay. Thanks everyone. Thanks for your valuable time. I will upload the
Thank you.
recording on the same path.
Yes.
Thanks.
yeah,
Sure.
thank you,
Thanks,
thank you,
Danish.
Thanks.
Danish.
Thanks. Bye.
Bye.
তুই think